Assalamualaikum warahmatullahi wabarakatuh. Today, we are going to demonstrate electromagnetic induction experiment, which is Faraday's experiment. In this experiment, we are going to use microammeter, crocodile clip, copper wire with different number of loops, which is this is 25 loops and this is 100 loops, and magnet. First step is we need to connect the crocodile clip to the copper wire with less number of loops, which is 25 loops, that connect to the microammeter. As you can see, when the bar magnet is stationary, the microammeter not show any deflection. When the bar magnet is moved relatively towards the coil, the microammeter shows a slight deflection to the right. Then, we will change the copper wire to the higher number of loops, which is 100 loops. As we can see, when the bar magnet is moved quickly towards the coil, the microammeter shows a greater amount of deflection. When the bar magnet is pulled out from the coil, the deflection is to the left. Based on the experiment that we did, Faraday's law states that the magnitude of induced EMF is proportional to the rate of change of the magnetic flux. This is the equation for Faraday's law, which is induced EMF equal to negative change of magnetic flux over change of time. Negative sign indicates the direction of induced EMF, always opposed to the change of magnetic flux based on Lenz's law. Therefore, when there is any relative motion between the coil and bar magnet, the current or induced current will flow momentarily through microammeter. This current due to an induced EMF across the coil. When magnetic flux through a coil change, which is magnetic field lines has been cut, thus the induced EMF will exist across the coil. The magnitude of the induced EMF depends on the speed of the relative motion.